All right, here is the third problem, okay? A 20 Newton textbook is pushed up by a 600 Newton man against the ceiling with a force of 25 Newtons, okay? So the first thing we want to do is look at the picture and see if he's just sort of standing there pushing that textbook, nobody's moving, okay? So the forces are going to be balanced, all right? And now let's try to draw our interaction diagram, okay? So we have, I'm just going to call this one book, because we don't have anything else that starts with a B. Okay, we'll have man. We have ceiling. Okay, and floor. And earth. Okay, I think that's it. All right. Okay, everything that's touching anything else needs to be included. Okay. All right, now, the man and the textbook, okay, they're obviously interacting. They're touching. And we want to think it's not gravity, right? Because it's not with the earth. It's not friction because nobody's moving or sliding or anything like that. So it's either going to be a push or a pull. Okay, so if he's pushing up against the ceiling, then that's going to be a normal force because that's going to be a push. Okay, similarly, the book is pushing up into the ceiling, all right, also with a normal force because that's a surface. That's a pressing together. Okay. And the man and the floor also are touching by pressing together on a surface, so that's a normal force. All right, the man is not touching the ceiling, okay, the book is not touching the floor, all right, and then everybody gets a gravity with the earth, okay, even the floor, if you want, you can leave that one out, nobody cares about it ever. Okay, gravity, and I guess the ceiling can get a gravity. That one's kind of weird too. Okay. All right. So the first thing we want to do is draw a thing with the textbook. That's called a textbook, but that's fine. All right. So let's look at the book first. Okay. So I can see here when I draw the system boundary for the book, I see 3 interactions that the book is having. Okay. All right. So I'm going to do the book and I see that, let's do the man first. All right. How is the book feeling the man? Oh, actually, let's do gravity first. I lied. Let's do gravity first, okay? Because that's always going to be there and down. Okay. Oh, wow, that was fancy. Better erase that because I don't know how I did that. Okay. All right, so force of gravity on the book from the earth, because that's the other object. All right, and that's 20 newtons, right? Because remember, when it looks like an adjective, like a descriptor of the thing, that is its force of gravity, okay? Or later next week, we'll learn that we call it its weight, okay? The man is pushing the book. Which way is the book feeling it? All right, I would say the book is probably feeling that upward, okay, with a force of 25 newtons, so that's going to be a little bigger than the last one. Okay, so Fn, book man. All right, and then they say that he's pushing with 25 newtons. All right, so that's up, and now I can see that these are unbalanced, but I need them to be balanced. Okay, so the only last interaction we have is the ceiling, and it makes sense that the ceiling would push down, but even if not, we know it has to because these have to balance. Okay, so this is going to be a little tiny one. Fn book ceiling, all right? And if I have to have a total of 25 down to match the 25 up, that's going to end up being 5, all right? Because 20 plus 5 down would equal 25 newtons up, all right? Okay, let's draw the man next. So let me look and see what's going on with the man. Okay, I also see 3 interactions for the man. Okay, and we'll start with his force of gravity, and it's 600 newtons. Okay, so this is obviously not really going to be able to be super to scale, okay, because that is just ridiculously different. Okay, so we're just going to do our best. So force of gravity on the man from the earth, okay, and that's 600 newtons. That would be a normal weight for a person, 600 newtons, force of gravity, okay. And the other 2 things pushing him are the floor and the textbook, all right. And since he's beneath the textbook, he's pushing up on the book, and so the book is pushing down on him. All right, so that textbook push, that 25, Fn on the man from the book, that's 25, that's going to be pushing downward on him. Okay? All right, and then the only thing left is the floor, and I can see I have a total here of 625 down. So that means I have to have 625 up. Okay, and I didn't really draw this super terrific, but so I'm going to have to go up into here a little bit because I really need those to look balanced, right? The total amount down and up needs to look the same. So that's going to be force normal on the man from the floor. I called it F. Okay, and that would be 625 facing up. All right. Okay, all right, and then the last thing we want to do is look for the Newton's third law pair, although I kind of already did that, right, when I said that that was 25. Okay, because see, FNMB, that's the other side of the FNBM. So there's my pair. Okay, because it's the same feeler dealer, same force type, it's just in the opposite direction. Opposite direction. Okay? All right, and that, I think, does it for that.